7.1, example 2. Graph the following quadratic functions on the same grid again. So again, our table of values are going to be filling in for each quadratic equation to help us plot our points to graph each. So a is y equals x squared plus 3x plus 1. So we're going to start with creating a table of values. Again, points don't ideally matter, but you want to try to pick ones that would make sense. So -4, -2, 0, 2, 4. And again, some positives and some negatives. As we know our parabola, we're starting to get familiar with the shape of that. And there will be some negatives and some positives. So plugging that in, -4, y equals -4 squared is 16, plus 3 times -4 is -12, plus 1. So 16 minus 12 is 4, plus 1 is 5. So when my x is -4, my y is 5. Same equation, but we're plugging in -2. -2 squared is 4, plus 3 times -2 is -6, plus 1 is a -1. Plugging in 0 wherever you have an x makes that whole group 0, so 0 squared plus 3 times 0 is still 0, plus 1 is 1. Plugging in our 2, 2 squared is 4, plus 3 times 2 is 6, plus 1 is 11. And our last point is 4, 4 squared is 16, plus 3 times 4 is 12, plus 1, 29. So plotting those points to the right. -4 and 5. -2 and -1. 0 and 1. 2 and 11. And 4 and 29. That's going to be way above. So we can start to see the shape here without plotting that last point. That's our blue graph. We'll do B in another color here. So a new table of values. Let's just leave our x's the same. So y equals -4 squared, which is 16, plus 2 times -4 is -8, plus 1, 17 minus 8 will give us 9. Plugging in -2, -2 squared is 4, plus 2 times -2 is -4, plus 1, which is just 1. 4's will cancel there. 0 squared plus 2 times 0 plus 1 again is just 1. 2 squared is 4, plus 2 times 2 is 4, plus 1 gives us 9. 4 squared is 16, plus 2 times 4 is 8, plus 1, which is 25. Okay, so plotting those points in red, -4 and 9. -2 and 1. 0 and 1. 2 and 9. And 4 and 25, which also won't show up. So if we can see the shape here, but I know I'm going to have a vertex still. Going through my red points. Keep our x values again. Oops, I didn't need to erase that. 16 plus. Okay, so our third one, C. Y equals x squared minus 5 plus 1. So y equals -4 squared is 16 minus 5 times -4 is plus 20 plus 1. So we have 16 plus 21 is 37. -2 squared is 4. Minus 5 times -2 is plus 10 plus 1. So 15. Plugging our zeros in again, we'll just have our 1. 2 squared is 4 minus 10 plus 1, negative 5. 4 squared is 16. Minus 5 times 4 is minus 20. Plus 1 gives us negative 3. So plotting those points, can't really do the negative 4 and 37. That's not on our grid, so we'll hop to negative 2 and 15. They'll be a little bit above, but we'll know roughly where that is. Negative 2 and 15. 0 and 1. 2 and negative 5. And 4 and negative 3. So we know it'll be opening up like this. Okay, one more. Do in black. Let's keep our x values again. Negative 4 squared is 16 minus 4 times negative 4 is going to be plus 16 plus 1. 16 plus 16 plus 1 is 33. Negative 2 squared, 4 minus 4 times negative 2 is plus 8, plus 1 is 13. Y equals 0 minus 0 plus 1, so again at 0 it's 1. 2 squared is 4, minus 8 times 2 is 8. Sorry, minus 4 times 2 is 8 plus 1. 8, 4 minus 8 plus 1 gives us negative 3. And our last point, 4 squared is 16, minus 4 times 4 is minus 16, plus 1, 16s will cancel and we're left with a 1. So 4 and 33 again won't quite be on our grid. Negative 2 and 13. Zero and 1. 2 and negative 3. And 4 and 1. This one's a little bit more narrow. All right. So to answer some of the questions, the value of b is changed, but a and c are left constant. So in our last graph example 1, we were changing our a values. Here we left our a and our c's the same. We always had an x squared plus something plus 1. So our b values were changing here. What effect did this have on the graph? So what we want to see is we can see it's moving left and right. So it moves left and right or up and down. Or up and down. What does the value of b tell you about the parabola? So how exactly was that changing? B doesn't tell us a lot, but we do see that it's moving left when our b value is greater than 0. So when it was a positive, it moved to the left. And our two negative ones, the green and the black one, moved to the right. So that is something we can say that we can tell with our b value. If our b value is greater than 0, the graph is going to move to the left. But if our b value is less than 0, so a negative value, it'll move to the right. It's the opposite of what it kind of looks like. So example 3 here, same thing, except now we can see our c value is going to be changing. Our a and b is staying the same. So plugging in a table of values, we want to plot these graphs to identify the change our graphs make when we change our c value. So let's say negative 2, negative 1, 0, 1, 2. Got some negatives and some positives. Plugging those into our graph. So graph A, y equals 2x squared minus 4x plus 1. Y equals 2 times negative 2 squared. So my negative 2 is squared, which is 4. Then times 2 is 8. Minus 4 times negative 2 is plus 8, plus 1, which gives us a 17. Same equation, but with a negative 1. So negative 1 squared is 1 times 2 is 2, plus 4, plus 1, 7. Plugging in our zeros, 0 minus 0 plus 1. 1 squared is 1, times 2 is 2, minus 4, plus 1. 3 minus 4 is a negative 1. And putting a positive 2 in, 2 squared is 4 times 2 is 8, minus 4 times 2 is 8, plus 1. Our 8's cancel, and we're left with a 1. So plotting those, negative 2 and 17. No, that'll be pretty high up here. Negative 1 and 7. 0 and negative, or sorry, 0 and positive 1. 1 and negative 1. 2 and 1. All right, next one, we'll keep our x values. Y equals 2x squared minus 4x plus 3 this time. So 2 times negative 2 squared is going to be 8, minus 4 times negative 2 is really plus 8, plus 3. 16 plus 3 is 19. Negative 1 squared is 1 times 2 is 2. Minus 4 times negative 1 is plus 4, plus 3, so 9. Zeros again. 0 minus 0, so now we're left with a 3. 1 squared times 2 is 2. Minus 4 times 1 is 4. Plus 3. 5 minus 4 is 1. And then plugging in our last point, 2. 2 squared is 4 times 2 is 8. Minus 8 plus 3, we have our 2 and 3. Plotting those points, negative 2 and 19. We know that's going to be pretty high up as well, outside of our recording area. Negative 1 and 9. 0 and 3. 1 and 1. And 2 and 3. So the graph looks pretty much the same for the most part, except it's now moved up a little bit. Keeping our x values, we'll put for a third graph, 2x squared minus 4x, now minus 2. So again, that's going to be 8 plus 8 minus 2. 8 plus 8 is 16, minus 2 is 14. Negative 1 squared, 1 times 2 is 2, plus 4, minus 2 is 4. 0 minus 0 is negative, minus 2 is negative 2. 1 squared times 2 is 2, minus 4 times 1 is minus 4, minus 2, negative 4. And plugging in 2, 2 squared is 4 times 2 is 8, minus 8, minus 2. So negative 2 and 14. Negative 1 and 4. 0 and negative 2. 1 and negative 4. And 2 and negative 2. So again, same width and everything, we've just moved it down 2. And our last one, same x values. Y equals 2x squared minus 4. And so if you don't see a c value here, it's really plus 0, right? If there's ever nothing there, It's not that it does not exist, it's just a 0. So negative 2 squared is 4 times 2 is 8. Plus 8 plus 0 is 16. Negative 1 squared, 1 times 2 plus 4 is negative 1 squared is 1 times 2, which is 2, minus 4 times negative 1 plus 4, which is 6. Plugging the zeros in, 0 minus 0 plus 0 is just 0. 0 and 0. 1 squared, 2 times 1 is 2, minus 4 is negative 2. And 2 squared is 4 times 2 is 8, minus 8 plus 0 is just 0. So negative 2 and 16, again way up there. Negative 1 and 6, 0 and 0, 1 and negative 2, 2 and 0. All right, so now let's look at what does our C value do. So the value of C has changed, our A and B were left constant. What effect did that have on our graph? So we can see that that moved vertically, whether it was up or down. So our y-intercept changed, but our graph's also moving up and down. So you can say any of the following. A y-intercept changes, graph changes vertically as well. Vertically is up or down. We didn't notice it getting wider, narrower, or moving left and right. All of our vertexes are pretty lined up based on accuracy for plotting points. What does the value of C tell us about the parabola? C is the y-intercept. Your y-intercept, always, just like how our b was in y equals mx plus b. So whenever your x equals 0, your y will equal your C value. And we notice that in our equation. Whenever we put in a 0 for x, our y value is always just what was left at the end because our x didn't make anything 0 on our constant. So whenever our x value was 0, our constant equaled our y value. Now, example 4, the graphs of 3 quadratic relations are shown below. We need to predict possible values of A, B, and C in the equation for each group. So it's not that we are necessarily going to be dead on for all of these, but based on what we know about what each of those values, A, B, and C, how they affect our graphs, we can try to pick relatively close variables for each. So in A, we want to come up with A equals, B equals, and C equals. So we know that it's opening up, which means it's going to be a positive. It's not very wide necessarily or narrow, so I would say a 1 or a 2. An original is probably about, if we look at C, that's what a regular quadratic would look like. So our A is a little bit skinnier, so we know that our graph is narrower if A is larger than 1, so we'll say it's going to be about a 2. And it's positive because it's opening up. Our B values from before, our graph moved right if our B value is less than 0. So our graph is right of the y-axis, so we know that our B value is going to be a negative value, and it didn't move very much, so let's say about a negative 1. Our C value, again, is our y-intercept. So we can see our y-intercept is at 1 in this one, so C, that one we could be more exact with as long as it's going through a direct point. So if we wanted to come up with an equation here, we could say y equals 2x squared minus 1x, or minus x, plus 1 would be an approximate equation for that quadratic. And we can always check that in our calculator to see how close we are. Again, we don't need to be dead on. We're just using what we've learned about each letter to try to identify and recognize those characteristics. Graph 2, it's opening down and it's wider. So right now I'm thinking my A value is going to be negative and it's going to be less than 1. So let's say about a negative 1/2. Now we're into fractions. Can't be less than 0, it just has to be between 0 and 1. My b value moved to the right again, so I know that it's going to be a negative value. And my c, my y-intercept, is at negative 1, 2, 3. So if I wrote that in equation form, y equals negative 1/2 x squared minus 1x minus 3. And graph C opening up, so my a value is back to positive and the original width, so I'm thinking a is a 1. B moved to the left this time, so B must be greater than 1, or must be positive, I guess, so we could say about, it could be a 1. And C's intercept is negative 2. So this graph could be about y equals 1x squared, or just x squared, plus 1x minus 2. Your assignment for 7.1, so just practicing recognizing how A, B, and C affect our quadratics, getting used to the properties of vertex, intercepts, domain, range, axis of symmetry, all those new terms. That assignment's on page 360, numbers 1 to 6.